Today in this space we will be talking about super macro technology. My name is Jesus Rodriguez. I am the Director of Production and Exploration at Nakazawa Resources. In the last few days we have been posting a lot about the different steam injection technologies. In this case we will talk about the conventional Ooteagodi technology of the super Matroid technology. Both technologies are manufactured by Nakazawa. The main difference that exists between them, taking the case of a steam generator of 25 million dBTU now, that in general more conventional, that we have been working with and we have been deploying in various places in a portable generator. The one that with one we can get 95% in steam quality and more, that is the technology is Super Matroid, and with hosting and conventional we can achieve around 80% of steam quality at surface level. Both equipments at their maximum capacity have a difference in heat generation due to the quality of steam that it produces. For example, with the Super Matroid we managed to obtain a round of about 27 million vehicles per hour, and with it Hay and conventional about 25 million bedicos per hour. Therefore when we inject with high quality steam we will have more effectiveness and we will have 10 to 12% extra heat. Following, knowing Super Matroid technology, I leave you a diagram which is quite explicit, where we observe the pumps in the heat exchangers or the radiation section, which is very important. The convection section, this part is very similar to the conventional generators that we add extra to this system. A cyclone separator with a mixing valve and also a superheater that sits between the radiant section in the convection section. That helps us to this cyclone separator helps us to separate this last fraction of between water and steam to obtain maximum safety. Super Tuesday, today we can divide it into two processes. The first process, which is very similar to conventional activities, that we have a convection section, a radiation section and steam heating that we can obtain in this area between 75 and 80% quality. We can go up to a little more. But we pass it to the second phase, which is the process of the innovation, which we can get to a dryness by passing the steam and the water through a superheater and coming up and coming down to the well a chance people of a 95 to 99% steam quality. The most important thing as a reservoir engineer is that we can transfer the greatest amount of energy to the reservoirs. For example, here various simulations were made at the level of heat loss from its surface to the reservoir using 95% and 80%. Simulations were made using insulated pipe and conventional pipe. If we go to the most optimal diagram using a conventional pipeline, if we inject 95% at 4,000 feet we would have 81%, and if we inject 80% we would have 66%. As we can see, there is a difference in the level of quality that is reaching our reservoir, and therefore less energy is going to be delivered to the reservoir. On the other hand, with 95% at surface level, we can guarantee more than 80% of steam quality within the reservoir, which is the most important thing that we have as executors of improved recovery projects. Thermal. And well, all of this translates into an increase in production, that is, with 95% steam quality, we have achieved through simulations and real field tests that we can increase between 21 and 28% extra compared to conventional technologies, and at a level yes production increase, and after steam injection we have obtained up to 400% in some wells. At the management level, a comparison between the two technologies, we have obtained by injecting a steam quality of 95%. We have had 25% less operational costs. Crude production increased between 15 and 28%. We have had less gas consumption. We have had greater efficiency of around 92%, lower water consumption and more heat injected. Thank you very much for having accompanied me today, and we will continue to use this space to explain a little more about our technologies and our advances every day. Thank you very much.